Okay, let's get on with today's lesson. We're talking about map work today, and you'll see that map work is actually very easy. We're going to look at scale first. Okay, so let's get straight into it. So now I've got a diagram here to help us understand scale. So here we have a diagram with a school bag. And in this diagram, in the corner there, as you can see, we have a ratio 1:15. All right, so in this diagram, they've given us a ratio 1:15, and that's going to help us interpret scale with this diagram. So there's a question here. It says the scale of the diagram is 1:15. Determine the real width of the school bag in centimeters. Now, let's have a look what it says over here. There's something that says NB, which means important. So let's go across and see what it says. It says, you need to remember that ratios, especially when talking about scale, ratios have the same units on either side. Okay, that's very important to remember. So ratios have the same units on either side. Now, I know you're thinking, Dale, where are the units in your ratio? Well, when it comes to maps and plans, the ratio, the scale that they give you, you can put any units there. You can have millimeters. I'll write it in for you. So 1 millimeter is to 15 millimeters. You can have centimeters, which is the norm that we use centimeters. So you can have 1 centimeter is to 15 centimeters. You can have meters, you can have kilometers, you can have inches if you want to. You can have footprints. You can have ice cream cones. You can have anything you want, as long as what is on the left has the same unit as what is on the right. Okay. Phyllis, I think we'll quickly go back to the scores here. So we've got quite a few people in top place in grade 11. There are 3 people with 14 out of 15. And then grade 10, we have 3 people with 15 out of 15. So those are the top 3 names at the top for grade 11 and 3 names at the top for grade 10. We got Luyanda, Janu, and Sitokozile in top 3 in grade 11, and Umpile, Vuyo, and Sonia top 3 in grade 10. Okay. So coming back to our ratio, we have the same units on either side of our ratio. Just remember that. It's very important. And how to interpret this ratio when it talks about maps and plans is that the number on the left, which is usually 1, okay, is your ruler measured number. And the number on the right, can be anything, is your measurement in real life. Okay, so if I interpret this 1:15 ratio for the bag, I'm going to choose centimeters. Okay, then 1 centimeter measured on this diagram will represent 15 centimeters in real life. Okay, I'll say that again. 1 centimeter measured on this diagram will represent 15 centimeters in real life. Okay, so now in this question about this bag, when they say determine the real width, the keyword there is the real width of the school bag in centimeters. They're not talking about ruler width. They're talking about the right-hand side here. Okay. So when they want the real width, you need to convert to 15 on the right-hand side here. Okay. But the first thing we're going to have to do is we're actually going to have to measure our ruler measurement of this bag from the diagram and then convert it to a real life measurement using our ratio. Okay, and it just so happens that I have my ruler with me. You guys don't have to worry about the ruler. I've got it here. So I'm going to move my ruler up here and I'm just going to go somewhere along this bag and I'm going to measure. And if you guys can see there, but it looks like it's 3 centimeters. Okay, so I measure 3 centimeters with my ruler. All right, so I'm going to erase all this quickly. Just remember the one on the left is ruler measurement and the one on the right is the real world measurement. Okay, so if I measure 3 centimeters on my ruler, what is that going to give me in centimeters in the real world? Can anyone tell me?
Pablo coming in fast. Fast on the field.
Yeah. Okay. Well done, Pavalo. All right, 45. Okay, so what is Pavalo doing? Well, he's saying, well, what did I do to go from my 1 centimeter from my ratio to 3 centimeters? that I measured in my ruler, I had to times it by 3. 1 times 3 is 3. So on the other side here, to go from our real world measurement to the real world measurement that they want here, I also need to times by 3. So the sum that you're going to do, the calculation you're going to do, is you're going to say 3 centimeters, and each one of those must represent 15 in the real world, so times by 15, and that'll give me 45 centimeters in the real world. Okay, so the real world measurement is 45, and my ruler measurement is 3. Okay, so 3 is to 45. All right, so I can write here 3 is to 45. Now, they don't want you to write a ratio. They just want you to tell them what is the real world width of this bag. So it is 45 centimeters. Okay. Cross multiplying is more with fractions, I wonder. We are kind of doing cross multiplying. We're multiplying on the left and we're multiplying on the right. But if you think of it like this, what are you doing to the 1 to get 3? You're multiplying by 3. You must do the same to the other side. So this calculation here is just showing the calculator steps that we're going to do on our calculator. Okay. So 3 times 15 to get to 45. All right. So it's not that difficult. Sonia, I don't know why you're worried. It's not that difficult at all. Okay. Well, let's have a look at another example over here. Where did the 3 come from? Ah, Chiama, good question. I measured it. See my ruler here? I've got this fancy ruler. And I used it to measure the bag, and I measured 3 centimeters on my ruler. Okay. So the ruler measurement is 3. They're asking, what is the real measurement? What is the actual width of the bag if you measure 3 centimeters off the diagram? Okay. Yes, Phyllis. So 1 times 3 to get 3, and then 15 times 3 to get 45. Very good. Okay. So if they give you a ratio scale and they want you to convert from what you measure on your diagram to what is in the real world, you can use that ratio scale to help you solve that problem. All right. Now, maps and plans, they often give you a ratio scale, but for maps specifically, they can give you another type of scale. So there's 2 that they can give you to work with. I wonder if anyone else can tell me what other scale do they usually give you to work with maps and plans. You've seen the ratio scale in action. What other scale do you guys know of in maps and plans that they give you? Bar scale. Who was that? Very good. Well done, Alzondi. Good. Line scale, same thing. Pabalo, well done. Bar scale and line scale, exactly the same thing. Very good, Sakile. Well done. Okay. So bar scale, line scale, exactly the same thing. All right. Good job. Well done. Word scale, Sakile. Yeah, they don't often give you a word scale in the question, but they could ask you to translate the ratio scale into words, which is very easy to do. So if you look at the ratio 1 is to 15, you can say, you interpret it as 1 unit of measurement on my diagram or my map must give me 15 of the same units in the real world. So if it's 1 centimeter on the diagram or the map, must give me 15 centimeters in the real world. So it's important to say something on your map must represent something in the real world. Okay. All right, fraction scale. Not really. They don't really use fraction scales that much. Number scale. To put a number scale is a type of scale called a number scale. This one here, the ratio one, is often referred to as a number scale. Okay, very good. All right, so let's have a look at this scale here, which is a bar or line scale or linear scale. Okay, so if you look at my diagram now, there where the school bag is, you will see a bar. All right, it works a little differently to the ratio. Okay, so here is the same statement. They say the scale of the diagram is 1 is to 15. Or they might not even show 1 is to 15. They might remove that. They say, here is a diagram, determine the real width of the school back in meters. So how to interpret this bar scale? So what you need to do is measure a portion of the scale. So in this case here, this bar scale's got a black bar at the front and a white bar at the back. So if we measure the first bar and get a ruler measurement for it, that ruler measurement must represent the real world measurement underneath. Okay, so if you measure this bar and you measure 1 centimeter, then underneath you can see it goes from 0 to 15. That black part of the bar, which measures 1 centimeter, must represent 15 centimeters in the real life. So these numbers underneath are often the real life measurement. Sometimes they will put numbers on the top. Okay, so sometimes they'll actually put numbers on the top like 0 centimeters and then 1 centimeter. So they'll actually give you the ruler measurements, but sometimes they don't. You actually have to get a ruler and measure it yourself. Okay, so sometimes they'll give that to you, the top one, the ruler measurement, but sometimes you'll have to actually use your ruler to measure it yourself. So let's pretend that we weren't given it. Okay, so what we're going to do is measure this first portion of the bar on our diagram and see what it is. Okay, so here's my ruler again. Okay, so if I take my ruler and I go up to my bar, don't know if you guys can see that, but that first portion of the bar, that black portion of the bar there, is exactly 1 centimeter. Okay, so to interpret this, one centimeter, this portion here, is exactly 15 centimeters in the real world. So the top part is the ruler measurement and the bottom numbers there are the real life measurements. Okay, so it's very similar to the previous question, which was 1 is to 15. 1 centimeter on my ruler represents 15 centimeters in the real world. Okay, so it's saying the exact same thing. It's just representing the scale in a different way. So you need to know how to interpret both of these scales. Okay, are there any questions about that? Everyone happy so far? So you must remember for this section in the exam, you're going to have a ruler with you. So please make sure you have a ruler. Besides a calculator, you need a ruler for this section as well. They might get you to measure some things on your diagrams. All right. Any questions about this? Anyone want me to go over it one more time before we try and practice this? Or are we all good and ready to go? Everyone happy with bar or linear scale and the number scale? If you're not happy, please raise your hand, put in chat, turn your mic on and talk to us before we get going into some questions.
Why is everyone so quiet?
I don't know. I think it's end of term, Kia. I think it's the end of term feeling. Everyone's kaput.
Yeah,
Everyone's
no.
tired.
I don't blame them. I feel it as well. Okay,
Yeah.
at least we have a reaction from Tiamo.
Yeah. All right, Akil, no problem. Okay, Akil, would you like me to explain the number ratio or the bar ratio? Or both? Akil, just type in chat there which one you'd like me to go over.
Kamo says both.
Both? Akil, both.
Yeah.
All right, let's do both again.
And then someone asked for the bar.
All right,
so
we're gonna do.
I think both.
We'll cover. Yeah, we'll cover all the bases.
I hope everybody's listening and they have their thinking caps on.
Yeah. Okay, so here's the scenario. There's a diagram. Yes, sorry, Kia?
Oh, I see Lisa Pele says they can't hear anything, so I'll help you now.
All right.
They can't hear. Never mind.
Okay. All right. So they'll give you a diagram and a scale on your diagram. So we see in this diagram, the scale is 1 is to 15. Okay. Which means that this image on the diagram isn't the real world image. It's been shrunken down. So the bag is much bigger than this. So this diagram image here is a shrunk down version of the real image. So we have to use a scale to work back to find out what the real size of this bag is. And they're telling us the scale of this bag compared to the real one is 1:15. So if we interpret the scale, the 1 is the diagram ruler measurement of the bag. Okay. And the 15 is the real world measurement of the bag. So what we're saying is for every one measurement, every one unit that you measure on this bag, it represents 15 of those same units in the real world. So in this case, 1 centimeter measured on this diagram must represent 15 centimeters of the real bag in the real world. Okay, so that's the relationship here. 1 on the diagram represents 15 in the real world. Okay, now the question is saying, we want you to go ahead and tell us what is the width, the real width of this bag. Okay, now the key here is to look at the word real. Okay, so if we look at the diagram, this isn't the real width. This isn't the real size of the diagram. We need to calculate how wide this bag actually is. Okay, so we're going to measure first with our ruler the width of the bag. All right, so you'll take your ruler and you will go up to your bag on the diagram and measure the width. And my ruler says that the width of this bag is 3 centimeters. Okay. So I've got 3 centimeters measured with my ruler. Okay. But now what does each centimeter represent? 15 centimeters in the real world. So how do I get to a real world answer here? So we need to multiply this 3 by 15 because every single one of them, every single centimeter represents 15 centimeters in the real world. So if I've got 3 centimeters measured on this bag, it must represent 3 times 15 centimeters, which is 45 centimeters in the real world. So this 45 is the real world width of the bag when I measured 3 centimeters, the width 3 centimeters on my diagram. Okay, I hope that's very clear. Let's look at the same thing. Akil, yes. Akil, you have a question. Akil, we're going to unmute you
now.
All right, Akil, can you hear us? Can you talk to us? Akil, you
Just
there?
unmute from your side, Akil.
There we go. All right, Akil. You can talk to us now, Akil.
Why is it that you have to multiply the 15?
Okay, good question. Thank you. Thanks for the question. All right. So the reason why we multiply is because of the relationship between the two numbers. Okay. So if I said to you, let's think of it like this. Let's say one person can carry 5 apples. One person can carry 5 apples. Okay. Then I ask you, Akil, how many apples can 4 people carry? How would you work that out? Akil, you there? You with me?
Yes.
So if I say one person carry 5 apples, how many apples altogether can 4 people carry? What would you do to calculate that? If one can carry 5, how many can 4 carry altogether if each one carries 5? And there's 4 people. If one can carry 5, 2 can carry 10. 3 can carry
15.
That's it. And 4 can carry
20.
That's it. So if 1 carries 5, how many can 4 carry? What kind of sum could we do? We could say 5 times 4.
4.
Okay, that's it. So if 1 has 5, how many will 4 have? We need to multiply that up. to get to the total of 20. It's very similar to how this ratio works. So this ratio says for every 1 centimeter on this diagram, you have 15 centimeters in the real world. So what if I measured 2 centimeters on my diagram? How many centimeters will I have in the real world? If one is 15, how many will 2 give me?
20.
Should give me double 15.
Oh.
Double 15 is 15 times 2 is 30, eh?
30.
Yeah. So how many will 3 give me? How are we going to work that out? Well, we can say to ourselves, let me write it like this. We can say to ourselves, what did I do to that 1 to get 3? I had to multiply it by 3. So what must I do to the 15 to get my number? I have to do the same thing. I'm going to multiply it by 3. So the sum I have to do is 3 times 15 equals 45. So the ratio, if you wanted to write it as a ratio, it would be 3 is to 45. Okay, so if 1 gives me 15, 2 will give me 30, and 3 will give me 45. And the sum we can do to go up every single time is multiply by 15. Okay,
Okay.
does that help a little bit?
Yes.
All right, can you guys still hear me? Is the sound clear? Just let us know if you guys are struggling to hear me.
From my side, it's perfect.
All right, thank you, Kia. All right, so here's the sum again. 3 times 15 equals 45. Okay. All right. So now I'm going to go down to the bar scale. All right. It's a very similar relationship, but it's in a diagram form. All right, not numbers. It's in a diagram form. Okay. So on the top of the bar, we're going to measure with a ruler, and underneath the bar, those numbers there are the real world measurements. All right. So what this means is you measure a portion of this bar, and we are going to measure the first portion of the bar, which is that black portion of the bar. Okay. So I'm going to take my ruler, and I'm going to actually, on my diagram, I'm going to measure that first portion of the bar, and I measure 1 centimeter with my ruler. Okay. Now the bar scale says for this much measurement of this black portion of the bar, you must have 15 centimeters in the real world. So we just so happen to measure that this first portion of the bar with our ruler is 1 centimeter. Okay. So if we had to think about this relationship, every 1 centimeter on this diagram must represent 15 centimeters in the real world. It's very similar to the ratio one we had. Okay, what if I didn't want to measure 1 centimeters? What if for some weird reason I like using even numbers and I would rather measure the whole thing? Okay, just so happens I want to measure the whole thing. Well, the whole bar is 2 centimeters. So my ruler measurement of the whole bar is 2 centimeters, and they're saying, well, this much of the bar, which is 2 centimeters, represents 30 centimeters in the real world. Okay, so then here's a question. What if I went to my bag and I actually measured that the bag's width? In fact, let's not do width, let's do length. What if I measured that the bag's length was 6 centimeters? Okay, then what would the real life measurement of the length of the bag be? If my ruler length of the bag is 6 centimeters, what would the real life measurement of the length of the bag be? Who can tell me? So I measure the length of the bag from the top down to the bottom, and I get 6 centimeters. What would the real life length of that bag be? Can anyone tell me? All right, we got an answer of 180 and an answer of 90. Anyone else? All right, we got 90 cent. Oh, let Tabo, you don't know how happy you just made Kia putting your units in.
I
Sonia,
love them units.
yeah, you just made Kia very happy. Okay, we've got 90s, and Akil's got 180. Ulweta's with 90. All right, I love it when we get different answers. All right, Minnie's got 90 as well. Okay, let's have a look. All right, I'm going to move my diagram over a little bit. And I'm going to move this bar over a little bit. And I'm also going to shrink it a tiny bit. I'll put it over there. Okay. All right. Let's have a look. Let's have a look and see. So we measured the length as 6 centimeters. Now, originally, I measured the first portion of this bar as 1 centimeter. Okay, so from there to there, it was 1 centimeter. So this part of the bar is 1 centimeter long with my ruler. And they are telling me underneath the bar is the real world length. They're saying your 1 centimeter measurement, this black portion of the bar, must represent 15 centimeters in the real world. Okay. So your 1 centimeter ruler measurement represents 15 centimeters in the real world. So if you get 1 centimeter ruler gives you 15 centimeters real world, what will 6 centimeters on your ruler give you in the real world? Well, every 1 gives me 15. So what do I do to the 6? I need to times it by 15 because every 1 centimeter is 15 in the real world. Okay, so I times it by 15. Let's use the calculator, get it to do the work for us. 6 times 15 is 90. So this bag is exactly 90 centimeters long in the real world because it's 6 centimeters long in my diagram. Okay. So you actually, with the bar scale, you actually have to get your ruler and measure it. If they don't tell you what that little portion is, you actually have to get your ruler and measure it. And then from there, do the calculation. Okay. Sometimes they'll actually write the ruler measurement on top of the bar like I've done. But sometimes you have to measure it yourself with a ruler. Okay. In the real world, sorry, Ntokozo, in the real world. Okay, so we're talking about the diagram world versus the real world. What's on my diagram versus what's in the real world. So in real life, this bag is actually 90 centimeters long, but they shrunk it down for my diagram here. Okay, so they're asking us, hey, this is a diagram. Here's a bar scale. Tell us, how long is this bag in the real world? It's real length. It's actual length. Okay, and we have to use that bar scale to do that for us. All right, I hope everyone's clear on this. Because now it's your time to shine.
Shine brighter than Rihanna's diamond, guys.
Yeah, shine brighter than the diamond. Okay. It is real length. That's it. It's real length. So if you had to see this bag in the shop, it's real length in the shop, not the length in the diagram. It's real length in the shop. Yeah, real length, real world length. I'll just use real length from now on. So here's a scenario. I'll read it with you. It says, the drawing alongside shows a plan of the dimensions of a bedroom. So we have a rectangular bedroom. Okay, it's a drawing of a bedroom. It's not the real thing. It's the drawing of the bedroom. Okay. Now this drawing is a rectangle, and it says here the drawing width is 6 centimeters. So this drawing on a piece of paper, its width, if you had to measure it with a ruler, is 6 centimeters. So this 6 centimeters here is the ruler width. And the 9 centimeters for the length is the ruler length, not the real world. This bedroom is not 9 centimeters in the real world. It's 9 centimeters on your piece of paper. Okay. And they give you a scale for this diagram. They say the scale for this diagram is 1:50. All right. So I'm going to help you translate that. All right. So 1:50. That means for every 1 centimeter on this diagram, it represents 50 centimeters in the real world. I'm using those words again. Okay, so 1 centimeter on my map measured with a ruler represents 50 centimeters in the real world. Okay, so that's the interpretation of this question. All right, so there's the information for you. So question 1, we're going to do that one first. Just question 1, and I know people are already doing it. Determine the real world length and width of the rectangle in centimeters. Okay, the real length and width of the rectangle in centimeters. Off you go. All right, now I'm going to check if you guys are working.
I see the boo was busy. I like
Good,
that.
good. We got answers.
Sonia already having an answer for us there.
There's Vivian with some answers as well. Good.
And they didn't forget their units. Are you seeing this?
Well done. Don't forget your units. Very good. Lokonolo, are you working there? How are the answers coming? All good? No. Oh dear. You want to ask a question about it? You're welcome to ask a question. Do you want to ask a question? We'll turn your microphone off. Hold on a second. All right, there we go. You have a question?
I don't understand.
All right. Let me help you a bit. Okay. So
Mm.
this is a
Mm.
diagram of a bedroom. So it's like we're looking at the bedroom from the top of the roof. If you were in the ceiling of the bedroom, looking down at the bedroom, like you were a bug on the ceiling of the roof, and you look down at the bedroom, you would just see a rectangular shape. Okay, it's the shape of the bedroom. It's a rectangle. All right. So it's almost like you're looking at the floor of your bedroom. All right. And this floor of the bedroom here, they tell you that if you had to measure it on your question paper, the width would be 6 centimeters and the length of it would be 9 centimeters. Okay, so they're saying in this diagram, the width is 6 centimeters if you measure with a ruler and 9 centimeters if you measure with a ruler for length. They're saying these are the diagram's dimensions. These are the measurements on the diagram. They want to know, what is the real length of this bedroom? They want to, so this is not, these centimeters here is not the real length. That's just for the diagram. So what they want to know, what is the real actual length and width of this bedroom? Okay, they tell you you can use this scale here to help you calculate it. So if you look at the scale says 1 centimeter on your drawing, on your diagram, will represent 50 centimeters in the real world. Okay, so if you have 6 centimeters on your diagram, how many centimeters in the real world? Well, what if it wasn't 6? Let me use a smaller number. What if it was 2 centimeters on the diagram? Well, I know 1 centimeter is 50 centimeters in the real world. So how many centimeters will 2 on my diagram give me in the real world? If 1 is 50, then 2 must give me. You can double it. So if one gives you 50, what will 2 centimeters give you?
Mm.
So we're timesing this by 2. You're saying 1 times 2 is 2. we do the same thing for the other side. You see,
Oh,
what will you get?
okay.
You can use the calculator. So we can say 50 times 2,
100.
100. Very good. So it's 100. So 2 centimeters measured on my diagram must give me 100 centimeters in the real world. Okay. But what if it was 6?
It will be 1 times 6. 1
Very
times
good.
6. Then it
1
will
times
be-
6. And then on the other side, we also times by 6.
Yes. Now I understand.
Okay, good. So 50 times 6 will give you
Then 6. 300.
absolutely. Absolutely. Well done. Good job.
Yeah, now I understand.
Excellent. Well done. Thank you. Okay. Let's go over the answers one more time. We've done the width. All right, we did the width here. I'm just going to write it out neatly again. So I'm just going to erase this and I'll write it out neatly again. Okay, so for the width, I'll write the width. We had 6 centimeters on our diagram. So to get to our real world measurement, we had to times this by 50. And we get 300 centimeters. I hope you write your units. Then for the length, we have 9 centimeters on our diagram. So we times that by 50 and we get 450 centimeters in the real world. So this bedroom's dimensions in the real world, the real dimensions of this bedroom is 300 centimeters by 450 centimeters. Okay. Now, question 2 says, convert your answers for question 1 into meters. Yo, there's a lot of answers here. Excellent. Convert your answers for question 1 into meters. Now, you got to remember the measurement course we did. These are metric units. You have to know how to convert in the metric unit system. You have to know that. They're not going to give you a formula for that. Okay. So for question 2, we're going to take our width. I'm just going to write width here again. We have 300 centimeters. To get to meters, what do we need to do? Anyone tell me? What calculation do we need to do to go from centimeters to meters? Pabalo.
Let me quickly unmute.
Yes, Pabalo, speak to us.
We divide by 100.
Very good. Thank you, Pabalo. We have to divide by 100 because there are 100 centimeters in every meter. Now, if you go back to the measurement course we did, you have to know your metric unit system. You have to know it. All right, you have to memorize it. Okay, so you divide by 100. So this will give you 3 meters because there are 100 centimeters in every meter. Okay, so the width is actually 3 meters and the length, we'll do the same thing. So we take our 450 and divide by 100 and we will get 4,5 almost right centimeters meters. Okay. All right, next question. Question 3. There it is on the screen. Calculate the real area of the rectangle in meters squared. And I'll give you a clue. All these answers that we've just got now for question 1 and 2 are real dimensions in the real world. So when they talk about real area, you can use these answers here. Okay, so calculate the real area of the rectangle in meters squared. Now, I haven't given you a formula for this. I'm hoping that you'll remember the formula for the area of a rectangle. Let's see if you can get it. Sakile. Hold on a second, Sakile. We're just going to unmute you.
You can talk
Yes,
to us, Akile.
Okay, can you hear me?
yes, we can hear you. How are you?
I'm good. I'm gonna say to calculate the area of the rectangle, aren't you gonna say A area is equal to length times breadth? And
Absolutely.
you're gonna
On the
take this from question 2, I think. Yeah.
absolutely well done. Thank you for that, Akile. Well done. Good job. Yes. Okay. So the area area equals length times width. That's the formula. Now, they should give it to you in the exam, but I wanted to test to see if you guys remember. Okay, so let's see. We're going to take these measurements now, all right, for question 3. So area equals length times width. All right, so I'm going to substitute my values in here now. So the length is 4,5 meters, and my width is 3 meters. And this will give me, let the calculator do the work, so 4.5 times 3. 13,5 meters squared. All right, square meters. That's what the question wanted. Let's check. They want the area of the rectangle in meters squared. Yes. All right. So we've given them the area of the rectangle in meters squared. Very good. Well done. And I love the units. You see that, Kia?
I love it too. Like, I'm so glad that we constantly keep reminding them.
Yeah, it's good. It's good. All right. Well done. Very good. Well done, Sakila. Good job. All right. Question 4. Now, question 4, I've written there grade 11. Grade 10s, you can do this if you want. But this is specifically for the grade 11s. Okay, let's have a look at the question. It says, if you wish to draw in a bed into this diagram, which has a real length of 2 meters in the real world, how many centimeters long will the bed be in your drawing? Oh man, there's a lot to this. The real length of this bed is 2 meters. How many centimeters long will it be in the drawing? Okay. Now, I'm not going to say anything else. I'm not going to give you any clues. I want to see who's firing on all cylinders tonight. I'll go back to the question. You wish to draw a bed into this diagram. Its real length in the real world is 2 meters. So what will its length be in the diagram?
We have answers popping in so fast.
These guys that put the answers in fast, I really worry. Their speed is fantastic, but is the quality good? The speed is incredible, but the quality good. So I'll say the question again. You want to draw a bed into this diagram. The real length of the bed is 2 meters. How many centimeters long will the bed be in the drawing? The speed is incredible, but is the quality good? You see, math literacy is all about interpretation of the question. Oh dear. Okay, I can tell you that none of these answers are correct.
Sambula has something different for us
Sambula's
there.
got something different. That's a bit different. $10,000 centimeters. Yeah. Oh my gosh. So this rectangle is only 9 centimeters long. How am I going to put 10,000 in there? This rectangle diagram is only 9 centimeters long. I can't put 10,000 in there. I think you're going the wrong way. You need to come back the other way. You zigged when you should have zagged. All right, there's 11.5 from El Zondi. See, this is why I only go over to the grade 11s, but watch, I think the grade 10s are also up for the challenge.
Yeah.
1,000, Sakile. You're going to make it very big. Akil's got 75, 4.5.
Everybody's just guessing at this
He was,
point.
yeah, it's like, okay, whatever. Let's just put a number down. I'm going to give it 1 more minute. I think someone's working furiously in the background. Run to course, it says 20. Babala's like, I'm done. I'm out.
Yeah, no. They're throwing in the towel. They're just
Tapping
like,
out. Like,
no.
I've had enough. Brahmi Lord. What was it they were saying at the end of the last lesson?
Yeah,
Oh,
fry
okay.
me, Lord, I'm your chip.
Is not make sure. There it is not make sure. That's it. All right, let's see. 1 or 2 more answers. Oh, yeah. Okay. Let's not make sure. All right, let me put you out of your misery. Okay. I'm going to read this question one more time. Let's read the question one more time. It says, so this is a drawing of a bedroom. And they say, if you wish to draw in a bed that has a real length of 2 meters, a real length, its real world length is 2 meters, which is normal for a bed, right? Beds are normally 2 meters long. But we can't put 2 meters onto this diagram. This is not a real world diagram. This is a shrunken down version of the real world. Okay, so they're saying it's a 2 meter bed in the real world, but you need to draw that onto this diagram, which has a scale of 1:50. So how long in centimeters must you draw this diagram? Okay, I'm going to give you the diagram now. Hold on a second. Bear with me. Even my Microsoft OneNote programs like that, so I had enough. We're going to have to restart it again. It's like load shedding.
Everybody's just going down.
Yeah, everything's going down. All right, let me quickly do it for you. I'm going to delete all of this quickly. All right, watch guys, watch carefully now. I'm going to go and do this question. So the real world length of this bed is 2 meters. Okay, they want to know in the drawing what must it be. Now you guys did the first step right. We need to first convert this into centimeters because scale, like I said, has the same units on either side. And our drawing is in centimeters. So we're going to work in centimeters. So you guys did the right thing by converting your 2 meter bed into centimeters first. Okay, you all multiplied by 100 and said, well, in the real world, this bed is 200 centimeters. That's correct. Absolutely right. The bed is 200 centimeters in the real world. But what is it on the diagram? On the diagram, 1 centimeter represents 50 in the real world. So every 50 centimeters in the real world represents 1 centimeter on my diagram. So if we go from the diagram to the real world and we have to multiply by 50, what do we do to go from the real world? What do we go from to go to the real world back to the diagram? We have to divide by 50. So we're going from the real world back down to the diagram. The bed in the real world is 200 centimeters. We divide it by 50. That gives us 4 centimeters in the real world. So on my diagram, I would use my ruler and measure 4 centimeters for the length of my bed. Now, there was someone that gave that answer.
Yeah, I'm
Ayan-
going through the chat right
Ayanda,
now, trying to see.
Ayanda, yes, well done, Ayanda. Sonia was close, 4.5. Sambulo, well done, Sambulo. Good job to those two. Ayanda and Sambulo there both got 4 centimeters. Sakile, so I'll explain it one more time quickly. So our ratio is 1 centimeter is to 50. Okay, I'm going to erase all of this other stuff. Or let's leave it there for now. So that means the ruler measurement on my diagram, if it's 1 centimeter measured on my diagram, it's 50 centimeters in the real world. Which means if it's 50 centimeters in the real world, it must come down to 1 centimeter on my diagram. So in the previous questions, we were going from diagram to real world, and we were multiplying. So if I write it like this, well, that's Thursday's letter. Let me write it like this, and then you'll understand. I'll write diagram and real world. So if we want to go from diagram to real world, we have to times by 50, because 1 on my diagram is 50 in the real world. It gets bigger, okay? But if we want to go from real world back down to the diagram, we have to divide by 50, okay? Because every 50 in the real world represents 1 on my diagram. So if I have 50 centimeters in the real world, how do I get back to 1? I divide by 50 to get back to 1. Okay, so you've got to divide by 50 when you're going from real world back to diagram. All right. Okay. So that grade 11 question was a little bit more challenging. We had to do 2 steps. Number 1, we had to first convert into centimeters. All right, so step 1, convert it into centimeters because our ratio and the map is in centimeters, so we need to work in centimeters. And then number 2, we need to go from the real world, I'll put here RW, back to the diagram, which is 4 centimeters. So we divided by 50. Okay. All right. Well done, Sakile. Okay, everyone. That's the end of today's lesson. This will be in the quiz, a very similar question, not the grade 11 one. The similar questions will be in the quiz on Thursday. Okay.